Okay, here are the notes for section 4.5. Just thought I'd write these down for some of you who maybe don't quite understand what's going on in this section. So maybe it's tough to see this. These are the two equations from the middle of page 324. Okay, so if you want to follow along in the book, you can look at page 324. Now, each of these letters means something. Each of these letters is going to change the sine function or the cosine function a certain way. Both of these functions, the letters will do the exact same thing to both of them. So we already know what sine is. Sine goes through the origin, okay, has a period of 2 pi, midpoint at pi. Okay, it never goes higher than 1, it never goes lower than -1. This is your standard sine wave, and of course it goes on for infinity beyond this both ways. Cosine's a little different. Okay, cosine, I'll just draw it right on top. Cosine starts at 1, goes down, actually it goes down like this. Okay, comes back up here, and continues on like that. But if you just look at one wavelength of cosine, from here to here, or let's just go from the tops to the tops, and this is in your book. It's much easier to see this in your book on page 320. So if you look on page 320, you'll see both of these functions, but the point I'm trying to get here with this first illustration is they both have a period of 2 pi. They both make one full wavelength in 2 pi. Okay, so how is that significant? Well, now we can start looking at what some of these numbers are up here. Okay, so the normal sine wave goes no higher than 1 and goes no lower than 1. Well, which number up here determines how high and how low we go? Well, the A does. If A equals 1, okay, our sine wave will go up 1, down 1. This will be 1. This will be 1. Okay? Well, if our A value equals 2, okay, we're going to go up and down, but now we're going to go up to 2, we're going to go down to 2. Okay? This distance is still going to be the same. And obviously I should draw it so it looks a little bigger. They look exactly the same, but just know that when A equals 2, we're going to go twice as high and twice as low. This should be -1, -2. So the zero line would be right here. Okay, and obviously you know what's going to happen if I change it to, how about if it's negative? Let's go A equals -2. Okay, well this time we'd start going down, up, and back down. Okay, we'd still get to 2, we'd still go down to -2, but we'd start going down first. We'd start by going down first if it's -2. But the amplitude, it doesn't matter what the sign is. The formula for amplitude is the absolute value of A. Okay, that's what the amplitude is. So if A equals 2, our amplitude is 2. If A equals -2, our amplitude in both these cases is still 2. Okay, because it's the absolute value. Okay, so that's the A value. It's going to change how high we go and how low we go. Everything else stays the same. We're still going to have the same wavelength. Okay? How about the B value? Okay, what does the B do? Well, B is associated with the period. Okay, if you know what B is, you can get the period by taking 2 pi divided by B. This is what the period is going to equal. Okay, 2 pi divided by B. Now this only works for sine and cosine, cosecant and secant. Okay, we're going to find out that tangent has a different formula. This formula only works for sine, cosine of an angle, cosecant and secant. Okay, this formula only works for those. Okay. So some problems are kind of difficult to try and figure out how to get your B value. So I'll just try one right here. This should help you with some of the homework problems. Let's say I have y equals 2/3 sine of, let's just go x over 3. And we have to find the amplitude, and we have to find the period. Okay, well, amplitude is A. A. Whatever's in front of the three letters, sine or cosine, whatever's in front of that, that's the amplitude. So in this case, our amplitude is 2/3. Okay? Our period always is this formula for sine and cosecant and secant. It's whatever number's in front of the x value. Okay, in this case, to get an x value of x over 3, what would I have to multiply? And I'll try and erase all this stuff so it's not so messy. Okay, what would I have to multiply x by to get x over 3? So what would I put out here to get x over 3? What do I multiply x by to get x over 3? Well, with a little bit of thinking, we come up with 1/3. It's the only thing I could possibly multiply x by to get x over 3. So our b value, this will always equal our b value, whatever we multiply x by. Okay, so how does that help us? Well, now we know our b value is 1/3. We can find our period by using our formula. Because this is sine, we can use 2 pi over b. b equals 1/3. Put it in. Okay, so it would be 2 pi divided by b. b is 1/3. When you divide by a fraction, it's the same as multiplying by the reciprocal. So this would equal 6 pi. So our period in this case is 6 pi.